So today we are going to learn about the stereochemistry of addition reactions. So the stereochemistry is very much important basically for competitive exams, and if we are saying for any entrance exams, for the basic understanding, stereochemistry part of each and every reactions in organic chemistry is way too important. So first of all we'll start with some basic points, and after that we will learn some basic examples so that we can solve any question in the exam related to the stereochemistry of electrophilic reactions. So, first of all, the stereochemistry of addition reactions depends upon 2 points basically. The stereochemistry of addition reactions depends upon 2 factors. We are talking about either electrophilic addition or either nucleophilic addition here, but we will more focus on both differently. So whether the electrophile and nucleophile will join themselves to make a double bonded carbons from either it can be a syn addition or it can be anti-addition. So if both electrophile and electrophile is represented as E positive and nucleophile is represented as Nu minus. So this is our electrophile and this is our nucleophile. So if I'm talking about electrophile and nucleophile, generally in any organic chemistry reaction, electrophile and nucleophile joins themselves. So electrophile and nucleophile joins together, as electrophile and nucleophile joins together to form the double bonded carbon atoms. Either if the joining of electrophile and nucleophile took place on the same side, then it's a syn addition, and if the joining takes place in the opposite side, then it's anti-addition. We will learn in more detail what's a syn and anti-addition. Basically you should understand, if on a particular double bond is converting into single bond and both the atoms that is added in a particular organic scaffold, because in a particular organic scaffold nucleophile and electrophile is going to add on the reactant basically. So if both nucleophile and electrophile add in same stereochemistry or on the same side basically, then that is syn addition. And if it is added on different sides, it means in opposite direction in different stereochemistry, then that is anti-addition. In the hydroboration reaction, if I must say, so if suppose bromine and hydrogen added in same, that we can say it's a syn addition. Hydrogen and bromine added in same direction on same side basically, so that is syn addition. But if the two things are added in different directions, suppose if we have added hydrogen in this way and we have hydrogen in this way, so this is anti-addition of hydrogen, because that is added in anti-direction basically in different stereo. So the geometrical orientation of the two parts basically of electrophile and nucleophile to each other. So you have to first be very precautious about the configuration of addition products basically. So you should know like how the electrophile and nucleophile enter. So you practice as many as reactions you can. After that you have to see either it's a stereospecific reaction or it's a stereoselective reaction. So if the electrophile usually forms a cyclic cation, that we've already discussed in the last lecture. We have already discussed about the addition of electrophile basically forming a cyclic cation as intermediate in the electrophilic addition reaction, and the nucleophile is no alternative but to attack the intermediate from the opposite side, and naturally the addition is anti basically. So in the nucleophile the addition is anti, but in electrophile we have studied about the electrophilic addition reaction in the last lecture, which is forming a transition state basically like this. So it's a very basic thing. If we have alkene, so if we have alkene as a reactant, we are going to add the electrophile in the form of reagent or in the form of reactant sometimes. So this electron density donated to this particular electrophile forming a intermediate, that is a 3-membered cation. So we have a classical carbocation. This is our classical carbocation. There are 2 types of the carbocations. First is classical and other is non-classical. So what you have to do is you have to know the difference between classical and non-classical. That we're going to learn in the basic concepts, basic electrophilic as well as electromeric concepts in organic chemistry. So after the formation of the intermediate, that is a classical carbocation. This is the classical carbocation. It's difficult to predict the stereochemistry. So when the carbocation is a relatively long life, so this may be undergo some rotations. So because this is not stable, classical carbocations are usually not stable, so it will go some rotations and carbon-carbon sigma bond usually breaks. So short-lived carbocations undergo the stereospecific reaction. For example, when the reagent is dipole in sense when the reagent is having a positive and a negative charge. So after the addition of the electrophile, because alkene sometimes I'm saying it's electrized as a dipole, part of the nucleophile forms an intermediate ion pair. So there is a formation of ion pair. So this is our ion pair with the carbocation, and in this case addition reaction is syn. There is syn addition of electrophile and nucleophile because they are adding in the same direction. So what I'm saying, when you have a reagent which is a dipole in nature basically, so after the addition of that particular reagent to the electrophilic part basically of the nucleophile forms an intermediate in the form of ion pair following by the carbocation, and it's a syn addition. So basically you just suppose here, if you have an electrophile in the type, you have just an electrophile and nucleophile basically as you are in the reaction along with the reactant. So you have to add in the same direction, so that it will, when the ion pair is forming in the three membered classical cation state, intermediate state, then you can go for a syn reaction. Now, reagents which forms the four-membered ring. So if we are going to learn about the more specific reaction, and when the four-membered classical carbocation basically I must say is forming, so that will also give some kind of syn reaction. And the example of that is BH3 and addition of hydrogen in the presence of catalyst, because if we have alkene just suppose, and we are going to add the H2 which is poisoned on the palladium surface basically, then we have a syn reaction, because hydrogen adds in the same stereo basically. Hydrogen adds in the same stereo, just like that. So this is syn reaction. So we have certain case when the electrophile is not equal to nucleophile, then addition is syn. What is that case? When the syn addition to cis compound, you are going to give the erythroform, just like that. When we have a nucleophile, when we have an electrophile, we have a alkene. We have an alkene, and basically we have cis alkene, just suppose, and that is forming electrophile and nucleophile in this way, then you are getting a erythroform. We all study about erythro and thrioforms in our 11 and 12 standards, so it's a very basic thing. You can understand the erythro and thrioforms by revising the stereochemistry lectures, which we have already covered in the second unit. So the erythro and thrioforms are also important in biochemistry part as well. So now, when we are going to syn addition to transalkene basically, so if we have transalkene, then what our product is? If we have transalkene and we are going to add electrophile and nucleophile, then there is a formation of thrioform. So you have to remember, if we are going to use cis alkene, we are getting a erythroform, and if we are getting trans, then we are getting thrioform. So like this you can remember the concepts. And when electrophile and nucleophile is not there and the addition is anti, how the addition is anti? It can be anti because if you are dealing with some examples, you will get to know which reaction is anti-addition, which reaction is syn addition. So that we will cover in basically name reaction part and the reagent portion basically. So from that you are able to understand and correlate your basics concepts. So anti-addition to any cis compound going to form the trio product. We have done the anti-addition, basically it's a cis alkene. Cis alkene if undergoes the anti-addition. So in the first and second case we have deal with the syn addition. Here we are dealing with the anti-addition. So that is a different thing. We have discussed in first and second about syn, and here we are discussing about anti-addition. So if we are going to add electrophile and nucleophile on an alkene and the addition is anti, you will get